Hey everybody, this is Larry. This is day 13 of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Happy Lunar New Year and all that stuff. Hope you're celebrating, having good health and all that, taking care of yourself. Let's look at today's poem, Shortest Path in Binary Matrix. So I go over and solve these live, so if it's a little bit slow, just watch it on higher speed or fast forward or whatever you need, because I try to go through my thought process as I go through these and not just a solution. Okay, so now you're given you're given a square matrix, empty or blocked. There's a path. It is connected directional, so it's not just up, down, left, right. It's also northeast, northwest, dot. Okay. You start from the top left and you go to bottom right, and you could go all 8 directions. Okay, the shortest such clearest path. Clear path. Okay. Yeah, I mean, I think what I was trying to think about doing is just trying to make sure that my understanding of this problem is right. So there's 8 directions. There's, technically there could be cycles, but the shortest path will not contain cycles because all the path weights are positive. In fact, in this case, this is 1. So you can do a breadth first search is probably my recommendation because it makes sense. And I think that's pretty much it, really. I don't know. Yeah. And that's basically what I would get started on. And yeah, given that said, that's going to be a prerequisite for this problem. So if you don't, or if you're not familiar with breadth first search, definitely practice it. But it seems like this is actually a very good problem to practice your breadth first search using a queue. And yeah, and I don't, maybe I'll go with, no, I mean, I think half of me wants to dig a little bit, but I don't think there's that much to dig in this problem that isn't going to be covered by any video that goes over breadth first search, because this is probably as textbook problem as it gets. The shortest path on an unweighted graph, right? So I'm just going to jump right ahead to the implementation. If you have, and I'm going to go over, the code as I type them, but definitely if you have questions, leave them in the comments, because I don't know. This one feels so textbooky that I don't know how to add additional value, because most breadth first search video will cover either this or something very similar. So yeah, unless I'm missing something obvious. Okay. Yeah, you just go. This is really awkward phrasing, but basically it just wants you to go for the zeros, right? Yeah, okay. And obviously my focus on implementation is going to be in Python, but definitely do what you need to do. But yeah, and in Python we're going to start. I mean, I always call it a queue by convention, but you would use a deck in Python. It has the same. I mean, it has a superset of the API that you want, which is pop left and append right, right? So yeah, and then here there are a couple of ways to do it. So this is just set up the queue. We can set up. Okay, let's also do n is equal to length of the grid, and this is a square grid, so we can set up scene is equal to yeah. So basically what this does is just sets up an n by n array that lets us know if we've been to a spot before. As we said, we want the shortest path, so it's going to be, as soon, like, we don't want any cycles, because if there's a cycle, then it's not going to be the shortest path. And then now we want to enqueue, and here I don't always do this, especially on a contest, but for clarity, I'm going to write an enqueue function, add an x and a y. We can add if. I want to call this maybe not just enqueue, but maybe possibly enqueue. but maybe we can do that in another function. So in queue, we put this on the queue. Oh, I guess there's a distance as well. And this is just a tuple with the distance x and y, and also we set scene xy is equal to true, and then maybe we can add a helper function that's possibly in queue, maybe in queue. Let's go maybe in queue, dxy. So we do if scene xy return if let's do the other gating first. If this is within n, so we return. This is the not version of this, of course, just to be clear. So this is, if this is our range, we early return. Otherwise, we include dxy. Also, that one more thing that we have to do is just to make sure that grid of xy is equal to 0. Oops, not equal. Right. And then now given all these helper tools, we can do maybe in queue of yeah, from the distance is going to be 0 at the corner, and then it's just 0 0. Yeah. And one more thing that the direction. Usually I write out directions, but I'm going to do something a little bit different this time, just to kind of give you a little bit variation. I think the other way is actually more Pythonic, but in a hunch and you're worried about typos, this is what I would do. But anyway, so while length of queue is equal to 0. I know that Pythonically speaking, you can also do while queue, but I like doing while length is, so that when I'm debugging, I know exactly what I want. And in other similar problems, it might be that this condition is a little bit off. Maybe you need 2 items in the queue, so I like to keep them explicit. But yeah, queue dot pop left, and then now what, right? And then now, if x is equal to n minus 1 and y is equal to n minus 1, we return d, because this is how buffer search works. The first time you pop it off the queue, it's going to be the first time that you the earliest that you're going to see it, and this is again very buffer search fundamentals, right? So yeah, and then now we do for dx in range from -1 to 0 to this is the thing that I like about other languages, is that you can have real for loops instead of for each loops, because this is exclusive, right? So this is actually just this plus 1, and this is going from -1 to 1 inclusive, but it looks very awkward here for sure. I agree. Yeah, dy, and then now we just do maybe in q. Nope, x plus dx, y plus dy, and then now we maybe in q d plus nx and then y, right? And that's mostly it, I think. And then we can now return, we do -1 or something, right? Yeah. Yeah, I think I'm happy with this. Let's do the rest of the test cases. I mean, I might have typos, but I think the general layout is pretty okay. I might just be off by 1 because I count the initial node as 0, because this is the length of this is the number of cells, not the length of the path, which, similar to the number of edges in a linked list or something, right? So yeah, so as long as I'm off by 1, did I do the same one twice? Oh, there are only 2 examples? Okay. So as long as I'm consistently off by 1, I'm happy, because we should fix that case anyway. Yeah, which is that here in the beginning we start with 1 cell for obvious reasons, and we'd like to at least test the -1 case. So let's do -1. Should be okay. Ooh, did I miss? Oh, I had an extra comma. A little bit slow. Okay. Yeah, it looks good. I mean, it's 32 milliseconds. I think the computer service is a little bit slow. So yeah, give it a submit. And it's going to be accepted. So what's the complexity of this, right? So this is going to be linear time, linear space. That's just how breadth first search works. You can, of course, n is not linear, right? The size of the input is n squared. So when I say linear time and linear space, I mean O of n squared time and O of n squared space. Yeah, and this is just basic properties of breadth first search, especially on a grid, because you can think about, if a breadth first search is going to be O of v plus e, where v is equal to the number of vertex, and the number of vertex is just n times n, and e is equal to the number of edges, which is equal to n times 4, right? Or sorry, in this case times 8 for going through the 8 diagonals. So obviously this is just going to be O of n squared, and for space, which is linear, in the size of the input. And in terms of space, most of it is going to be dominated by this scene array, and also this Q, and both of which will be adverse n squared, so also linear. So one thing that I actually kind of I thought about mentioning, but I forgot because I did it, is that here we actually check dx dy is equal to 0, but because of the maybe and q, and that we checked for scene and we set it, it just gets it just happens to be false by default because you don't move. It's a self cycle of 1, self loop of 1. So yeah. That's all I have for this problem. I cannot quite fit this on the same page to show you, but this should be good enough, most of it. Let me know what you think. And yeah, is that Valentine's Day? Yeah, maybe it's a little bit early. But for those lovers out there, happy Valentine's Day, and I will see you tomorrow. Take care of yourself, take care of others, stay good, do well, do good, do well, and to good health and to good mental health. I'll see you tomorrow. Bye bye.